Okay, so the next topic that we're doing is looking at discrete random variables. So this was a 2016 question on discrete random variables. And a discrete random variable usually comes in a table. So if you have a look at this table here, we should know that the bottom always adds up to 1. So the probabilities always add up to 1. And we'll get on to do the other bits and pieces as well. So it says here, write down an equation in terms of P and Q. So we've got all these things here that add together to make 1. So we add that together and simplify. We've got 2P plus we've got a Q plus 0.5. That equals 1. So if we tie that up a little bit, we've got 2P plus Q equals 0.5. And that's our first mark. We're now told that E of X equals 0.4. Now, if you're doing the revision on this, this is one of the key things that you need to know. So the expected value of X is done by doing this times by this times by this times by this, that, and then add them together. So if we do that, for part B, make it a little bit bigger there. For part B, we have got minus 2P minus Q. A half times 0.2 is going to be plus 0.1. You've got 0.3 times 3 over 2, which is 0.45. Then you've got plus 2P. And that's how you find the expected value of X. So this times this, 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 then add them all together. And we're told that it equals 0.4. So now we've got to find the value of P from that. So minus 2P plus 2P, that cancels out. You've got 0.1 plus 0.45, that's going to be 0.55 minus Q equals 0.4. So Q equals 0.15. So, oh sorry, yeah, that was to find the value of Q. Hence find the value of P. So now we know that Q equals 0.45, and we've got this thing here. We've got 2P plus 0.15 instead of Q, and that equals 0.5. So 2P equals 0.35. So P equals 0.175. And there you go. Given also that you got E of X squared, is that find the variance of X. Now the variance of X, if I just write down the information that we've got up here, we're a bit tight for space on this question. So we had P is 0.175 and we've got Q which was 0.15. So we've now got to find the variance of X. Now the variance of X, we can write that down as the variance of X equals E of X squared minus E of X squared. Now what this means is E of X squared, if I just explain how to do that, what they've done is if they've squared this value here and times it by the probability. They've squared this value here, times it by the probability. Squared, times by that. Squared it, times it by this. Squared it, times it by this. So all of those are squared. Then you times it by the probability. You then add it up and that gives us E of X squared. So in theory we could have done that. We could have done minus 2 squared times by P, which was 0.175, minus 1 squared times Q, a half squared times 0.2. Either way, it gives us this thing here, which we've been told. So the variance of X equals 2.275, take away E of X. Now E of X is our mean. And we're told that E of X is 0.4, so we're going to take away 0.4 squared. So that's what you do in your calculator, 2.275 minus 0.4 squared, and that gives us 2.115. Now Sarah and Rebecca play a game. The computer selects a single value of X using the probability distributions above. So what they mean by that is they're going to select a value, and it's been based on these things here. If I just tidy that up a little bit. And we now know that P is 0.175, Q is 0.15, and P is 0.175. So continuing on this question, Sarah's score is given by the random value S equals X. So therefore Sarah's score is going to be -2, -1, a half, 3 over 2, and 2. And Rebecca's score is given by the random variable 1 over x. So it's going to be 1 over, so Rebecca's score, if we write them above, is going to be minus a half, -1. 1 over a half is going to be 2. 1 over 3 over 2 is 2/3. And 1 over 2 is going to be a half. Now we've got to find the expected value of r. So what we do is we do minus a half times 0.15, -1 times 0.15, 2 times 0.2, 2/3 times 0.3, a half times 0.175. And so again, what we do is we'd write down the workings for that. So minus a half times by 0.175 plus -1 times by 0.15 plus 2 times 0.2 plus 2/3 times by 0.3 plus 1/2 times by 0.175. If we do that, that gives you 0.45. Sarah and Rebecca work out their scores, and the person with the highest score is the winner. If the scores are the same, the game is a draw. Find the probability that Sarah is a winner. So if we have a look at our table over here on the left, what we want to know is when Sarah's the winner. So let's say the computer picks -2. That means that the Rebecca score is going to be minus a half, and Sarah's score is going to be -2. And so we've got to find the highest score. So in that case, minus a half is higher than -2. So in this case, Rebecca would be the winner. In this case, it would be a draw. If we have a look here, Rebecca would be a winner if the computer picked out a half, because Sarah would get a half and Rebecca would get 2. If we have a look and the computer picks out 3 over 2, Sarah gets 3 over 2, but Rebecca only gets 2 over 3. If the computer picks out 2, then Sarah gets a 2 and Rebecca gets a half. So the ones where Sarah's the winner is if the computer picks out 3 over 2, because that's bigger than 2/3, and 2, which is a half. So the probability that Sarah's the winner is going to be this probability plus this probability. So it's going to be 0.3 plus 0.175, which equals 0.475. The probability that Rebecca is a winner, well, when Rebecca is a winner, is when the computer picks out -2, because Rebecca scores minus a half then, which is bigger than -2. If the computer picks out -1, neither of them are a winner because they both get the same value. If the computer picks out a half, then Rebecca gets a score of 2. So Rebecca's a winner during this value here and this value here. So that's going to be 0.175 plus 0.2, which equals 0.375. And that's how to work out that question. I mean, that's quite a tricky version of the question, but either way, that's how you do it. So look at the 2015 question on this. Let's get it into the screen first of all. Okay, there you go. So in the quiz, the team gains 10 points for every question it answers correctly, and loses 5 points for every question it does not answer correctly. The probability of answering a question correctly is 0.6 for each question. Let's underline that, it's important. One round of the quiz consists of 3 questions. So the discrete random variable x represents the total number of points scored in one round. The table shows the incomplete probability distribution of x. Show that the probability of scoring 15 points in a round is 0.432. So let's go back. The quiz consists of 3 questions. So you've got question 1, question 2, question 3. And you get 10 points if you answer a question correctly, and 5 points if you do it incorrectly. So if you've got 3 questions, to get 15 points, you've got to have 2 correct and then 1 incorrect. So you can either get correct, correct, incorrect. So how many different ways can you do that? So you can get correct, correct, incorrect. You can get correct, incorrect, correct, or incorrect, correct, correct. So if any of those combinations come up, it means that you're going to have 10 points, 20 points, and take away 5. You can have 10 points, take away 5, and then another 10 points. Or minus 5 plus 10 plus 10. Either way, you'll end up at 15 points. And these are 3 ways in which we can do it. So we've got to work out the probability that we have a correct question, and then an incorrect question. So that's going to be, the probability for a correct question is 0.6. So it's going to be 0.6 times by 0.6 times by probability of an incorrect question is 0.4. Okay, so, or we could have done it this way, correct, incorrect, correct, which is 0.6 times by 0.4 times by 0.6. Next one, 0.4 times by 0.6 times by 0.6. And then what you do is you add those together. Or you can notice that all 3 of them are the same. So you just work out one of them, then times it by 3. So 0.6 times 0.6 times 0.4 times by 3. And we should get 0.432 if we do that. The probability of getting 15 points is 0.432, which is what we got. So that's what we need to do. So we need to add those together. And then we get this thing here. So 0.432. Find the probability of scoring 0 points in a round. Now, just like the previous question, we've got to know that all the probabilities have to add up to 1. So we're going to do this plus this plus this, then 1 take that away. Or take it away from 1. So 0.216 plus 0.432 plus 0.064. Take that away from 1, and you get 0.288. So that's A and part B done. Find the probability of scoring a total of 30 points in 2 rounds. But now what you've got to do, again with these questions, is you've got to work out all the different combinations. So in order to get 30 points in 2 rounds, I'm going to have round 1, I'm going to have round 2. I could get 30 points in the first round, or I could get 0 points in the second round. Or I could get 15 points in round 1 and 15 points in round 2. Or I could get 0 points in round 1 and 30 points in round 2. If I get minus 15 in round 1, there's no way I can end up with a total of 30 points in 2 rounds. So again, what I've got to do is I've got to work out those totals. So the probability of scoring 30 and then 0, that's going to be 0.216 times by 0.288. The probability of getting 15 in round 1 and 15 in round 2 is 0.432 times by 0.432. Next, I've got to get 0 in round 1 and 30 in round 2. So that's going to be 0.288 times by 0.216. And I multiply them and then add them together. And if you do that, you end up getting 0.31104. So again, statistics, 3 significant figures, 0.311. So now what we've got to do is we've worked that out. We've now got to find the expected value of x. And again, this is something that we've done up until this point in the previous question. So it's again going to be the same thing. So you've got to do this times this, this times this, this times this, this times this, and add them all together. So workings, I want to see 30 times by 0.216 plus 15 times by 0.432 plus 0 times 0.288 plus minus 15 times by 0.064. Obviously, if you don't write that one, that's fair enough because it's 0 times. But if you do that, you end up getting the answer as 12. So that's the expected value of x. And now we've got to do the variance of x. So just like before, what we do is we square these values here. And you times it by the probability, and that's going to be the value of ex squared. It's going to be 30 squared times by 0.216 plus 15 squared times by 0.432 plus 0 squared times by 0.288 plus minus 15, put that in brackets, because otherwise it's easy to take away 15 squared rather than doing minus 15 squared, times by 0.064. Now that's going to give you e of x squared. And what we've then got to do to work out the variance is take away the expected value of x, which we know is 12 squared. So from this, we've got to then take away 12 squared. And so if you do that, obviously that's going to, 12 squared is going to be 144. So e of x squared, if you type all this into your calculator, and that should give us 306. So 306 take away 144 gives us 162. Now, in a bonus round of 3 questions, this is the trickier question, and this made a lot of people struggle. In a bonus round of 3 questions, a team gains 20 points for every correct answer, or it answers correctly, and loses 5 points for every question it does not answer correctly. Give the expected number of points in the bonus round. So again, what they're asking for here is e of x. So what we're going to do is we're going to go back and we're going to have a look at what we've done so far, because all these probabilities here in our table, that's for getting 30 points, 15 points, and 0 points, and minus 15, but they've changed the scoring system. So all we're going to do is we're going to look at the probability of getting 2 questions or 3 questions right, 2 questions right, 1 question right, and 0 questions right. So 0 questions right would still be minus 15 points, because you're going to lose 5 points for each question. If you get all 3 questions right, it's going to be 20, 20, and 20, so that's going to be 60 points. If you get 2 questions right and 1 question wrong, it's going to be 20 points, and take 5 points away, it's going to be 35 points. And again, there's 3 different ways of doing it, and in the exactly same way as last time, it's going to give us 0.432. If you get 1 question right and 2 questions wrong, that's going to be 20 points you gain, and take away 5 points, take away another 5 points. So that's going to give us 10 points. And so this is what the distribution looks like now. And then you just do it in exactly the same way. So the expected value of x is going to be 60 times by 0.216 plus 35 times by 0.432 plus 10 lots of 0.288 plus minus 15 times 0.064. You type that all into your calculator, and in doing so you get the nice answer of 30. So again, it's all about the understanding of what the question's asking you in this type of question. Okay, so the remaining question on discrete random variables is this thing here. So what we've got here is what we call a probability function. Now, in all the discrete random variable questions, I try to get it looking like something I recognize. So here, we're told that our x values are either 2, 4, 6, or 8. So what I'm going to do is I'm going to write down what my x values are. 2, 4, 6, and 8. And I'm going to write down the probability that x equals x. So if this tells me that to work out the probability when x is 2, I'll substitute it into this. That's going to be 2k. The probability of 4 is going to be 4k, because you replace the x with the 4. You then replace the x with the 6. That's going to be 6k. Now if you substitute, now 8 is on different levels, so therefore you've got to substitute 8 into this one. So substitute 8 into that, and that's going to give you 6k. Now, just like the previous 2 questions, if we add this bottom line of probabilities up, it has to add up to 1. So 2k, because this is a show that question, so you want to put in a few more workings. So 2k plus 4k plus 6k plus 6k equals 1. So that's 12, 16, 18k equals 1. So k equals 1 over 18. And that's it. So then what we can do is we can replace our table here. Instead of 2k, that's going to be 2/18. You can simplify that down to 1/9 if you wish. That's going to be 4/18, 6/18, and 6/18. Now, I mean, the reason that I left it in terms of 18 is because it makes the next bit a little bit easier. Now we've got to find the exact value of f of 5. Now, this f letter here, what that means is we're going to add up all the probabilities up to and including our x value of 5. So this is less than 5, this is less than 5. Our next value of x is actually more than 5. So we're not looking for that. So f of 5 means all the values up to the value of 5. Now it's a little bit misleading because 5 isn't actually one of our values. That doesn't make any difference because all we're looking for is things that are less than 5. That's going to be 2 and 4. And so the probability of that is going to be 2/18 plus 4/18. So that's simply going to be 6/18 or a third. Okay, now we're going to find the exact value of e of x. So, just like we have done in the previous two questions, e of x is going to be these things here multiplied together. So 2 times 2/18 plus 4 times 4/18 plus 6 times 6/18 plus 8 times 6/18. And you do that on the calculator. And that gives you 104/18, which is 52/9. 4/9 goes in there 5 times, is that 5 7/9? I think it's about right, yeah. Find the exact value of e of x squared. Now again, it's something we've looked at. E of x squared, you need to square our values and times it by the probabilities. So it's going to be 2 squared times by 2/18 plus 4 squared times by 4/18 plus 6 squared times by 6/18 plus 8 squared times by 6/18. Then you work that one out, which equals 112/3, which is 37 1/3. So again, that's ex squared. Right, now we've got to work out the variance of this thing here. Now there's a couple of ways of doing that. First of all, let's just work out what the normal variance is. So the normal variance we know is e of x squared minus e of x squared. So e of x squared we just worked out was 112/3, and we're going to take away the expected value of x, which was this one, 52/9 squared. And in doing so, we get 320/81. So now what we've got to do is we've got to work out the variance of this thing here. Now this, again, it's a good revision point, so we're going to take this a little bit slower. So if we've got variance, so variance of 3 minus 4x. Now we know what the variance of x is. So to work out the variance of something like this, what we do is we ignore anything here that isn't to do with the x, but we take whatever's in front of the x, in this case minus 4, and we square it. So we're going to do minus 4 squared times by the variance of x. So that's going to be 16 times by 320/81, which equals 5120/18. It says to 3 significant figures because it's stats, which is going to be 63.2. And there we go. Right, now, like I said, I want to do a little bit of revision on this. So if we've got, if we had, say, the variance of 6x minus 3, then what we do, so this is a completely different question, don't get confused. 63.2 was the final answer to this one, and then that's all 3 questions done now. But just another teaching point, if it said variance of 6x minus 3, what you do is you ignore this minus 3 on the end, in fact, just get rid of it. Whatever's in front of the x, we square it, so that's going to be 6 squared, and we times by the original variance. So 6 squared times by the original variance. If, however, we had to work out the expected value of 6x minus 3, or 6x minus 3, then what we do is we would have a look at the thing in front of the x, and we do 6 lots of the expected value of x, and then we take 3 away. So with a variance, whatever's in front of the x, we square it times by the variance of x, and just don't worry about the extra bit. If it was the expected value of x, we just do whatever's inside the brackets. So whatever the expected value of x is, if it was this case here, we times it by 6 and take away 3. And that's how that works. Okay, well done if you got to the end of this video.